find the general solution to AX is equal to B when A is equal to this matrix here, and also B is equal to each of these four options. Hint: for parts B, C and D, it may be helpful to find a particular solution first. Alright, well, let's understand the question first. What does general solution mean? General solution to this matrix equation. Well, general solution means it would have like S's and T's in there or something. I mean, if there only came out to be one solution, then it would be the general solution. But otherwise, it'd have all those free variables and things. So that's what I'm aiming for. And what about a particular solution? Well, a particular solution would just be one particular vector with actual numbers in it that solves the equation. Don't have to get all of them, just one of them that actually works. So why would it be useful to have a particular solution and a general solution? Oh, that's right. See if I can remember this. If the general solution to AX equals 0 is X equals G, some vectors G with like an S and a T or something, and a particular solution to AX equals B is X equals P for particular, then the general solution to AX equals B is X equals P plus G. That's what we're going to be using, I reckon. Okay, well, it's good that B equals 0, 0, 0 is first, because I can find the general solution to that first and then use it for my other answers. Let me start a new page. So, A. So we've got 2 minus 4 minus 2 minus 3, 6 minus 12 minus 2 minus 7, minus 1, 2, 4, 3 is equal to 0, 0, 0. And I'll do row operations until I get to reduced row echelon form. So let's see. We want a first column of the identity here, which means we want a 1 here. Well, there's a 1 here. Admittedly, it's a minus 1, but we can swap rows to get it into the right spot. So let's see. My new row 1 and row 3 will be equal to my old row 3 and row 1. So I haven't changed row 2, 0, and I've swapped row 3 and row 1. Okay. So now I'd like my column of the identity here and a 1 there, but I'd also like zeros below, and I can see that if I made this a 1 and then tried to subtract multiples of that here, I'd have all these negative numbers that I'd be subtracting, and I'd be heaps more likely to make a mistake. So I'm going to add multiples of this negative 1 to these to make them 0 first. So let's see, my new row 2 will be equal to row 2 plus 6 of row 1, and that'll be 6 plus 6 times minus 1 is 0, so that'll do that. And my new row 3 will be equal to row 3 plus 2 of row 1, and that'll get me a 0 down here. Okay, so let's do it. haven't changed row 1. Let's put that in. And so 6 plus 6 of minus 1 is 0. Minus 12 plus 6 of 2 is 0. Minus 2 plus 6 times 4 would be minus 2 plus 24, which would be 22. 7 plus 6 times 3 would be 7 plus... oops-a-day, I've forgotten to copy a minus sign from above. See, there's a minus sign here and I didn't copy it down. Oh, I was getting a bit scared that my numbers were going to be huge. Minus 7 plus 6 times 3 would be minus 7 plus 18, which would be 11. And 0 plus 6 times 0 is 0. Okay, now let me do my row 3. 2 plus 2 times minus 1 is 0. Minus 4 plus 2 times 2 is 0. Minus 2 plus 2 times 4 would be 6. And minus 3 plus 2 times 3 would be 3. And finally, 0 plus 2 times 0 would be 0. Alright. So where are we up to? We still need to have a 1 here. So we'll do our new row 1 is minus row 1. So my new row 1 will be minus. So 1, minus 2, minus 4, minus 3, 0. Okay. Now I'm going to have to put a 1 here anyway. So I might as well divide by that 22 now. So my new row 3 is equal to a 22nd of row 3. And so that'll be 0, 0, 1, a half, 0. And I guess I could just as easily divide by this 6 here if I really wanted to. So I could do my new row 3. Oops-a-day, I actually did that operation on row 2 before. That was my new row 2, half of row 2. And my new row 3 is I could do a sixth of row 3. And I'm doing that to make my subtraction a little easier later, because I might as well make them the same now. 0, 0, 1, a half, 0. And I kind of did it also because I noticed that if I divided by 6, these two rows would be the same, which would be a lot easier to cope with. Okay, so now I finally have my identity matrix here and a 1 in the right spot. So move on to the next column. But this is already as close to the identity. That's similar to the previous column, and so I can't find the next column of the identity here because I can't get a 1 in this spot by swapping from rows below or anything like that. So let's move on to the next one, and I'd want a 1 here. Okay, I've already got a 1 there, so I just need the zeros above and below. So my new row 1 is equal to my row 1 plus 4 of row 3. And my new row 3 would be not 4 of row 3, 4 of row 2. That red circle is the one I should be using to get rid of numbers above and below. And my new row 3 is row 3 minus row 2. And so I haven't changed row 2. So my new row 1 is row 1 plus 4 of row 2. So 1 plus 4 of 0 is 0. Minus 2 plus 4 of 0 is... 1 plus 4 of 0 is 1. Minus 2 plus 4 of 0 is minus 2. Minus 4 plus 4 times 1 is 0. And minus 3 plus 4 times a half would be minus 3 plus 2, which would be minus 1. And finally, row 3 minus row 2. Well, row 3 and row 2 are the same. So I just get this. And so now I've got a column of the identity there, and the 1 in the right spot. So what I'd want next is a column of the identity here with a 1 further down, but I can't achieve it because there's a 0 there, so I'm in my reduced row echelon form. So next I need to find the general solution, and to do that I'd need to know which of my variables are free. So to do that I should look for my leading ones. So there's a leading one here, and then going down to the next row there's a leading one here, and going down to the next row that's all zeros. So I've got two leading ones, and the remaining columns represent the columns that free variables go in. So my free variables would be here and here. Notice that there's always a solution because 0 plus 0 plus 0 plus 0 is 0, so I'm alright there. So I let my free variables be something like s and t, and then I solve these equations in terms of s and t. So suppose my variables were x1, x2, x3, and x4. I'd say let x2 be equal to s, and x4 be equal to t for s in R and t in R. Okay, so let's write what these equations mean. My first row here is x1 minus 2x2 minus x3 equals 0. x1 minus 2x2 minus x3 equals 0, and so therefore x1 will be equal to 2s plus t. Since x2 is s and x3 is t. Now going back here, my next equation would be x3 plus half of x4 is equal to 0. So x3 plus half of x4 is equal to 0. So x3 would be equal to minus a half of t. Alright, so putting all that together, we get x1, x2, x3, x4 is equal to, or x1 is 2s plus t, x2 is s, x3 is minus a half of t, and x4 is t. And I could rewrite that in terms of the s's and the t's, which is tradition. So I would have, let's see, a vector with all the s's in. So I have, let's see, oh, sorry, 2s plus, let's see, 1s there. No s's there and no s's there, so 0, 0. Plus t, so let's see, I've got 1t here. No t's there. Minus a half of t there. And 1t there. Okay, so that there is the general solution for AX equals 0. Now let's do part B. Well, for part B, the hint says I might need to use particular solution, and we know that if I can find a particular solution, I just have to add on what I got for AX equals 0, and that will be the general solution for AX equals B. So what I want is I want AX is equal to minus 1, minus 1, 2. So I want 2, minus 4, minus 2, minus 3, 6, minus 12, minus 2, minus 7, minus 1, 2, 4, 3, times some vector to be equal to -1, -1, 2. And this vector here that does the trick is my particular solution. It's a length 4 vector because it has to match with this length across here. And there's a way of doing it by thinking about matrix multiplication by a vector in a certain way. So I know that if I put some numbers here, A, B, C, D, then that would be A of this column plus B of this column plus C of this column plus D of this column. Because if you think about it, you'll do 2 times A minus 4 times B minus 2 times C minus 3 times D, and that will go in the first position. 6 times A minus 12 times B minus 2 times C minus 7 times D, and that will go in the second position. And minus 1 times A, 2 times B, 4 times C, and 3 times D, and that will go in the last position. And you notice that all of these got multiplied by A, and all of these got multiplied by B, and all of these get multiplied by C, and all of these get multiplied by D. So I just need to think of a combination of the columns that does what I want. So what combination of the columns can I do? Alright, well, let's see. Let's see, I want a -1. Well, there I haven't got any -1s, but I could try and achieve it by doing a multiple of one of the columns. So let's see, I could divide this one by 2, and that would give me -1 here. So that would be a half of column 3. Let's see if a half of column 3 will do what we want. Half of column 3. So half of column 3, minus 2 times a half would be -1, minus 2 times a half would be -1, 4 times a half would be 2. Excellent! It's just a half of column 3 and none of column 1, none of column 2, a half of column 3 and none of column 4. That produces the correct answer. So that's my particular solution. So this is my particular solution there, 0, 0, half 0. So therefore general solution is 0, 0, a half 0 plus S of 2, 1, 0, 0 plus T of 1, 0, a half minus a half 1 for S and T in R. So what that means is if I want to produce any other solution, I just need to choose particular numbers for S and T. So for example, I could just as easily choose maybe S to be 1 and T to be -1, and I could figure out what that vector is and put it here, and it would produce this answer. Let's do the next one. So there's my matrix A, and I would like a vector here so that it comes out to, this time it's supposed to come out to -7, -15, 8. Alright, let's see. Well, if I added -4 and -3, that'd give me -7, so it could possibly be column 2 and column 3. Let's just have a look at column 2 and column 3. Column 2, column 3. -12 -7 is -19, and it's supposed to be -15, so that's not going to work. But 2 and -2, if I put them in as well, it's not going to change my answer. It's still going to come out to -7. So if I put in all of the columns, so 1 of column 1, 1 of column 2, 1 of column 3, and 1 of column 4, then that would give me 2 -4 -2 -3, which is still -7. -12, 6 plus 6 would be -6, -2 would be -8, 8 minus 7 would be minus 15. It's looking promising. Minus 1 plus 2 would be 1. Plus 4 would be 5. Plus 3 would be 8. Excellent, it worked. So that's my particular solution. So therefore, the general solution is 1, 1, 1, 1 plus S of, looking back to the other page, 2, 1, 0, 0 plus T of 1, 0 minus a half 1 for S and T in R. Well, we've only got one to go. Let's put that in. Right, this time I've put in the A and the particular solution, and this time it's supposed to come out to minus 2 to 7. Alright, well let's just check to see if it is a multiple. Well, it can't be a multiple of this. It's not the same as this. No, it's not a multiple of any of the columns, so it's going to have to be something more complicated. So I need to do a combination. So, look, if I added these two together, that would give me minus 2. So if I had column 1 and column 2, let's just check to see if that works. Column 1, column 2. 2 minus 4 is minus 2. 6 minus 12 is not 2, so that's not going to work. Alright. What about if we did this one minus 2 of this? That would give me minus 2 as well. So what if I did this and this, only instead of doing 1 of that column, I do 1 of column 1 and plus 2 of column 3. Because then, let's see, 1 plus 2 times minus 2 would be minus 2. So 1 times 2 plus 2 times minus 2 would be minus 2. 1 times 6 plus 2 times minus 2 would be 6 minus 4, which is 2. Minus 1 times 1, which would be minus 1. 4 times 2 would be 8. Yes, that comes out to 7. So it's 1 of column 1, none of column 2, 2 of column 3, and 0 of column 4. I'm sorry if I said column 2 instead of column 3 as I was working that out. Okay, so therefore the general solution is the general solution is 1, 0, 2, 0 plus S of 2, 1, 0, 0 plus T of 1, 0 minus a half 1 for S and T in R. So every time I change the answer, the B, I just have to change this bit and not this bit. Excellent, I'll remember that for next time. That's the end of the question.